Organization is key.
Oh no, oh, it's recording. Let the fun begin.
There you go. You got your wish. Well, welcome everybody to class number 3 on our energy series. Today, as I'm sure you noted from the class assignments, we're going to talk about fossil fuels. But before we jump into it, I kind of wanted to give an opportunity again to review any of the concepts from the previous material on electricity, just to see if anybody had any questions or on fossil fuels regarding the assignments or questions that you had to answer. Well, maybe we can do a quick concept review and it'll help jog your memory.
Mr. Mike,
Yes, sir.
can I be the co-host?
No, sir.
Okay.
We got it from here. Appreciate the offer. So we talked about electricity last time, and we said electricity is really electrons moving along a conductor, delivering energy to either give off light or create motion, meaning, turning electric motors, turning, I don't know, let's say the blades of a blender. That's all electricity in motion, right? You can use it to generate heat, cook with, heat your home, etc., and a wide variety of other things, right? Mm-hmm. And there were two main sources for creating electric current. Can anybody tell me what those were?
Fossil fuels.
And nuclear.
Solar.
Two main sources. Solar is one of them.
Natural gas. Coal.
I'm looking for a different thing that we talked about last time. A specific device that's used to generate electricity, not a fuel.
Generator.
There you go. Yeah. And we delineate or separate these two from each other because they make electricity differently, right? The vast majority of the world's electricity is produced with generators, which we said is, we looked at the coiled copper wire in between the magnets, the rotor and the stator, and going around and inducing an electron push force. That's the way we generate most of the electricity. How we turn that shaft is through different ways, like using, Levi, I think I heard you say nuclear, which is really just used to produce heat that makes steam that turns a turbine blade that turns the shaft of the generator, right? Or you can burn natural gas or fossil fuels, what have you. Solar panels use energy from the sun, the photons, across N-type, P-type silicon cells that allow electrons to be freed and travel along copper conductors and induce a flow the same way. Everybody remember all that?
Yes.
Awesome.
Mr. Mike?
Yes, sir.
So for wire, let's say wire, like if you have a extension cord coming out of a plug, how many electrons would flow through that wire in 10 days?
Yeah, I'd have to calculate it for you, bud, and it would depend on what's pulling those electrons.
It would be a big number.
Remember, electricity flow is based on the demand, right? But I'm glad you brought that up. That electric cord is actually like a mini model of our electric grid, right? It's the transmission lines through which the electricity is delivered to the things that need to use it. We saw last time maps of the different grids and how North America is managed by the regulators of the grid, or the people who actually sell us our electricity. It is the connected infrastructure that takes electricity from the generation plant, from the end of that generator. We said it steps it up to a super high voltage so it can be sent over, transmission lines, long distances. And by the time it gets to where it's going to, go ahead.
Doesn't it step it down, the transmitters on the line?
The transformers do the step up and step
Transform.
down, and transformers can be either. They can step up voltage or they can step it down, right?
Oh, okay.
It works both ways. The plant increases the voltage or steps up the voltage so it can be sent long distances and have enough voltage left so that when it gets to where it needs to go, you can step it down and it still has the usable amount of energy that you need to run the appliances in your home or the lights or what have you, or an industrial process if you're using it for that.
Plus, Miles, if you can calculate the current, which you can, coming out of your wall socket, and you know that there are about 6.2 times 10 to the 18 electrons per second, you can back calculate
And
how
right.
many seconds you have there, and you can get how many electrons total if you know the current coming out of your wall.
My dad might help me with that because he's a whiz with math.
Well, good. That's awesome.
I would assume you could get it too because it's multiplication, right?
Yep.
I'm good at
I have all the faith in the world. All right, so to change gears a little bit, no pun intended, we are going to focus on fossil fuels today. Fossil fuels is kind of a broad description, but before we got into that, I kind of wanted to do a scene set a little bit. We talked before a little bit about emissions. We've mentioned them. We haven't really described what they are or why they're important. But if you continue to study energy, you'll find that different sources of energy get compared by the benefits they provide and the costs or risks that come along with them. So to kind of define what we mean when we talk about emissions, I gave a couple of definitions here. Both the word emit and emission have the same Latin origin, which I won't try to pronounce because I don't know Latin, but it really means to send forth, throw, or give out. If you think about a light emitting diode or an LED light, it emits light by giving off photons as current passes through it, right? So when we talk about emissions from different fuel sources, we're talking about the things that are byproducts of using those fuel sources, right? And this could be anything from nuclear and nuclear waste, or burning fossil fuels and the emissions that come out of burning those to create the electricity. But it's not to say that emissions are limited just to those things. It's just common today to hear, because of how we use them to judge a fuel source, associated with making energy. Right? So what are fossil fuels? Are we literally burning fossils?
No.
No, that's not it.
No,
It's like
that's
the
right.
fuels that take millions of years to make and like aren't unrenewable.
That's right. We call them fossil fuels because the things that we are using were around back when some fossils were created, right? Millions of years ago. Does that make sense? We're not actually burning fossils. Like if you do an internet search for a fossil, that's not what we're burning. It's not the rock. Unless you talk about coal. A synonym for fossil fuels is hydrocarbons. Now, hydrocarbons has a broader definition, but it's really a hydrogen-carbon molecule chain, right? So all fossil fuels, because they're made from organic matter that has been decomposed over time, compressed, and cooked, have these hydrocarbon chains in them, right? So you'll hear these terms if you do any future study or unit study outside of this. You'll continue to hear some of these terms.
I have a question for everyone. Who watched the rocket launch last week?
Me. We
The
did.
rocket launch
Me.
last week?
I did. You
Yeah,
texted
The
us about
SpaceX.
I
it,
did.
but we didn't see it.
Who knows what fuel they burn?
Methane and
Hydrogen.
oxygen, I think. Oil?
No, it
Blue?
wasn't. It was some sort of gas. It
Meth-
burned
methane,
gasoline.
methane and oxygen.
Yeah.
So they burn methane and oxygen.
No, I thought
They
it
had
was
to make
liquid
'em-
oxygen.
They have to make them liquid, right? So they are normally gases, but they had to make them liquid. But that's what Mr. Mike was saying. That is a hydrocarbon, right? Methane is just a CH4. So they were burning hydrocarbon to rocket to space.
Levi, to your point, it was mixed with liquid oxygen, right? Because we know that in space, you got to take your own oxygen to make combustion happen.
Right. Yeah, that's combustion. Right.
And oxygen's a catalyst. So it
Yeah.
helps you get all the power you can out of burning that each molecule of methane.
Mhm.
But that's a good point. And we're going to talk about methane today. We sometimes call it natural gas. That's kind of a commercial or trade name for it, but the chemical name is methane. And we'll get to that at the end of this one today. I wanted to start with one of the more basic hydrocarbons or fossil fuels, coal. There were two different sections in the study, one just on coal itself and then one on clean coal. And I'll always put clean and dirty in parentheses because they're kind of subjective terms. But we'll learn more about what it means to be clean or dirty when it comes to an energy source. Can anybody tell me what coal is? How it's formed?
What steam trains
It's a
eat?
rock. It's like carbon, right?
It has carbon, yes. Miles, did you say steam transmits coal?
No steam trains.
Steam trains. Yeah, old locomotives used to burn coal to make steam. That's right. Which would actually be powered. It would power the gears on the train to make it go.
I think I believe it was compacted
Organic matter.
organic matter, I believe.
Yeah, all on the right track.
Under
All good
heat
answers.
pressure.
That's right. There was
It's made by heat and pressure.
there was a question in the material that I think a lot of people got tripped up on when it asked for besides time and temperature, what else was needed to make coal? And the answer was pressure. Some folks put chemicals. I think there was a wide variety, but you have to remember when they're quizzing you on those things, they're trying to trick you just a little bit, just to make it a challenge. But really, when we talk about hydrocarbons or fossil fuels, those are three commonalities that they all share. At least in the large commercial quantities that we find them in and refine them from. You need time. Most of these sources are millions of years old. You need heat to cook them or reduce them down to their hydrocarbon form, and pressure as well. Especially when we talk about coal, pressure is important because the plant matter that coal is formed from, that was buried and compressed and cooked a long time ago, turns it into a sedimentary rock. Actually, I think the video called coal the rock that burns. And just like the charcoal on your grill, which is a derivative of pure coal, that you would find in the earth, you find this stuff as a solid piece of rock that you can put in a fire and burn. And we do. It turns out that a lot of the electricity we generate across the globe comes from burning coal. And that was for a number of reasons. It was available. It was affordable. It's fairly cheap to refine.
Cheap, simple,
And-
and available.
That's right. It's fairly simple. You don't really have to do anything else to it besides take it out of the ground and throw it in a fire. or burn it, ignite it, right? Interesting in that it's one of the kind of one of the oldest forms of sources of energy, especially for electricity. Miles, I see your hand up. What's up, bud?
So like when they're mining a coal mine, is like somebody was smoking, they had a match and the match dropped on the ground and all the coal in the mine started catching on fire and the mine burned down.
Mine fires are one of the reasons, and that's a good point. One of the questions had to do with cost benefit pairs, and one of the answers was that coal mining was safe. And I think the point you just raised is that because coal burns, if you have an ignition source in a mine, you're surrounded by coal and you're literally digging it out of the earth, and you light a fire in there, is that going to be a good day?
No.
It's not. It's not at all. Right? You're literally surrounded by combustible material. So a coal mine fire is a bad thing. Not only for the people inside, but they're difficult to put out once they start burning. You can look up coal mine fires and you'll get a few examples of how once a coal mine ignites, it continues to burn because it just keeps burning underground and nobody's going in there to put it out. You almost have to flood the mine to try to extinguish the fire.
Who knows the animal that was used in coal mines?
Bird, a canary.
Donkey.
A donkey? Yeah.
Wait, why did you say a bird?
I've never heard that anybody. put
Because they
animals
did
in
use
coal-
birds.
They did use birds.
That's right.
Why
they can
did
detect
why
them.
did they put
Oh,
Miss
sorry.
Tara gave you the answer.
Sorry. No, someone else
They
can
put-
say it.
They put birds or canaries in cages as like a portable methane detector. So every time there was methane in the coal mine, the bird would like either die or act weirdly, and that's how they knew.
Like it was because they use a lot of oxygen.
That's not very nice to the birds.
But I mean, that's
It's
how
very nice
back
to
then
you.
That's how they.
It's for science. It's fine.
It's science.
It's very
For
nice to you.
science.
But it would warn the workers
name
at the
of
coal mine they need to get out because there's a lot of methane gas, right?
Mhm.
Which is bad.
Which
Yeah,
my question
can't-
is why it would affect the bird first, and then
You know,
us.
it's a good question.
Bird's smaller, right? He's smaller,
Wait.
so he's like he has like
Sensitive.
he needs less.
They're sensitive
To-
to the methane.
Yeah, that's what I heard as well in the lecture. It was that the birds were more sensitive to methane than people were, so they were better detectors of higher concentrations of it. Why that is, I'm not sure. If it's something specific to birds, I don't
Mother
know.
Nature.
Yeah, now we have gas detectors. So they don't have to use canaries anymore. So. What are some of the drawbacks to using coal? We talked about it being cheap, easy, simple, but what's wrong with that?
There's
Impact the
there's a
environment.
lot of it, and it's on
Okay.
high demand.
CO2
And
emissions.
if you burn it, it'll make smoke, and that'll like pollute the area with CO2.
That's a big one. Go ahead, Desi.
Oh, I said the same thing. I said CO2 emissions.
Okay. Grace, you had a comment?
It destroys the environment.
How so?
Well, when we try to mine coal, we destroy forests and the ground to dig it out of the earth.
Yeah.
And like CO2 emissions makes air pollution. And we also just drive animals away from their homes by doing that.
That's a good point. All of those are true. We tend to think of coal as being dirty. And again, I put it in quotation marks because dirty is a subjective term. What we mean when we say that is that the emissions that come from burning coal are not environmentally friendly, either to us or to animals or to the world in general. When we start to talk about emissions like greenhouse gases that are proven to contribute to global warming by thickening the ozone layer, the atmosphere, and creating a insulating effect on the Earth, not allowing heat to escape into space. There are some detrimental things or some harmful things that can happen if the temperature of the Earth rises too much. Emissions and dirty energy sources, contributors to that, are labeled dirty, right?
I was thinking that like maybe you would be able to capture the carbon emitted from the power plants before it gets like in, you know, like it's like it gets into the atmosphere.
Spot on.
And then you could like fly a rocket to space and release it all in space.
You could. That's a disposal method for sure. Just run a pipe out into space. Save the rocket. Just run a pipe out into space, right? And just let it go out there. Yeah, that's a great idea. I love the imagination. And we'll talk about that in just a second when we talk about clean coal, right? Because that's one of the approaches. Is there's two ways you can address the negative emissions that coal puts out, and that's one of them, right? Is to clean it up after you burn it. Specifically, coal puts off nitrogen and sulfur compounds that have other effects. The NOx compounds, or the nitrogens, the sulfur, and the acid rain that can result from that. It also gives off CO2, which we know is the greenhouse gas, as well as solid particles. It turns out that breathing solid particles, like if you lived next to a coal burning power plant and those solid particles weren't captured after it was burned, it's not great to breathe those in. Your lungs were meant to breathe air, not solid particles. Interestingly enough, you know, this is science that has come to the forefront. You know, the importance of studying what chemical reactions give off is recent, right? In modern history, it's a recent development that we've understood that the repercussions of our actions in producing energy to develop need to be thought about more diligently. I think the one important thing to say here also is that coal is a very old energy source. It's been around for a very long time. There's still a lot of it left. And every modern country to date, including the United States, has developed on the backs of coal.
Is it possible to use the smoke and emissions that coal makes after being burned to turn a generator?
Well, you'll find that they use the majority of the heat that's produced from burning coal to create steam that powers the generator. The emissions that come off of the, you know, directly out of the stack, or I guess we'll just go to the next page because it's illustrated. You're talking about the black stack here on the left-hand side of the screen, and what's coming out of the top of it labeled emissions to turn a generator.
Yeah.
You probably could, but you're not going to get anywhere near the amount of electricity generation from that as you would the steam that you're creating with the heat from burning the coal.
Would it be possible to do both?
You could, yeah. That's actually called cogeneration. And we haven't covered that, but it's trying to make a process more efficient by using the waste that comes out of it, like the emissions in this case, to do something else. And if you use that to generate a little bit more electricity, well, I mean, you're actually generating a little bit more electricity.
And that also probably means a little bit less coal you would have to use, which means a little bit less emissions going out.
Well, I don't know that you would use less coal because you're still trying to power that main generator primarily, right? That's your goal, is to keep that thing up and running, and what comes off the top, you could get a little bit more benefit out of potentially. But I think, as we'll see, like the push to make coal a little bit cleaner takes those emissions and does something else with them. That would
Mr.
probably
Michael?
make it useless as far as generating electricity. But so clean coal. Does anybody remember the two ways that we try to make clean coal?
They were catching the ashes from it. I remember those.
Removing the solid particles we talked about that are harmful to breathe for people in the area. Yep. So that's the post process, right? That's after you've used it primarily. You can reduce the emissions that it gives off by capturing some of it or cleaning it up. There were, I think the terms they used were like bag house and air scrubbers. Really, our vehicles do the same thing. Every car,
I think,
after a certain date, had to have a catalytic converter on it. Yes, Miss Tara?
oh, no, I was going to ask Emma about that because we were talking about that today. Emma, what's a
Yeah.
catalytic converter?
It
I know what it
convert-
is.
Oh, someone know what it is?
Miles?
Yeah, it's a filter that goes in the exhaust fan of a car that removes waste from the exhaust.
Yeah, it's,
Cars, I think cars beyond 1992 had them.
yeah, it's like a ceramic coating. So it has platinum, palladium, and rhodium. And those things, the catalysts, right? That when all those nitrogen oxides and all those carbon monoxides and stuff come out, can then combine with those metals. And so what you're left with is a less dangerous CO2 and oxygen.
CO.
Yeah.
Yeah, so that, again, that's another good example of post-processing. And there's similar mechanisms or processes we can use to try to help reduce the harmful emissions that burning coal produces. Another way is on the pre-processing side, or before we actually burn it. We can try to remove some of the CO2 from the coal, right? Now you have to turn it into a different phase to do this. So you have to kind of pre-cook it before you put it into the fire, but it actually just removes the total amount of CO2 in the coal, and that CO2 gets captured and pulled off to the side and stored, and then you burn the rest of the coal to produce the steam. In any regard, coal is still one of the most emission producing fuel sources that we have available to us. The advent of clean coal, or introducing these other processes to try to clean it up a little bit, has kind of a negative feedback loop associated with it, because to do these things, you have to spend more energy, you have to spend more money, which kind of begin to weigh against the benefits of coal being simple and being cheap, right? So anything extra you have to do to it decreases the value of it. Makes sense?
I guess.
You guess? There will be a Kahoot at the end of the lesson. All right. Oil. Everybody familiar with this one?
Yes, I love the smell of
Yes.
gas and diesel.
Awesome. Oil is extremely prevalent in our day-to-day lives, meaning in your household, there are probably no less than 100 things, if not more, that are derived from oil or one of its distillates, I'll call them, the things that you can make from oil. We know that oil is different than coal because it comes from mostly plankton or insects, animals, or still organic matter, but critters, let's call them, that were buried. Yeah, that they lived
The
millions of
dead
years ago.
plankton that sank to the bottom of the ocean, and they were
That's oil.
layered and layered with sedimentary layers, and they all, with pressure and heat, they went solid, and we drilled for it.
They didn't go solid. Oil isn't a solid. It is
Well,
a liquid.
the rock.
And yeah, that's right. Oil lives within the pore spaces of sedimentary rock in most cases, right? In its most economic version, it is a pressurized liquid in the pore spaces of the rock. So it's pressurized by the amount of rock that's stacked on top of it, and maybe if it's connected to some other things like aquifers, they can add some pressure to the reservoir. But this is all in subsurface or underground reservoirs that we tend to find most of the oil, which is why we have to drill for it. But it's a very versatile product, meaning you can make a lot of different products from it, right? Not only the gases, like we talked about, if you can see on the right, the petroleum gases like propane and butane and all the different other anes that come from it, but gasoline for cars, diesel fuel, jet fuel, waxes, working your way down this picture of a distillation column, you can see even lubricating oils. There's a ton of products that come from refining oil into its different distillates. Transportation in general, which we said is one of the top 3 uses of energy in general, right? In the first lecture, we covered that. Transportation relies so much on oil that some say it could be a point of exposure for the globe, right? Meaning if something were to happen with the global oil supply, transportation would be affected very badly. Say again, Grace?
Drastically.
Yes. Pick your adjective. It would be bad. because transportation relies on it so much, right?
It would be cat exterminatingly bad.
Let's go back to horses.
You were just
Honestly, I
saying
think
poor
you'd be putting
canary.
a horse everywhere.
Hey, horses are still being used today. Why not continue using them?
I'm honoring the canary with my little bird on my screen.
The horse is going to have a bone to pick with the canary because he's getting off easy, but the horse has to go back to work.
The horse has been working longer than the canary anyways.
Has it?
Yes, people still use horses.
I remember in one of the things that I read, a fact about miniature horses or ponies. They were used in coal mines.
They were.
Yeah.
Because they were smaller than horses.
Yeah, to pull
Aren't
the carts
donkeys
of
also
coal
used
out of the
in
mine.
mine?
Yeah. Anything that could pull, I'm sure it was used to pull a cart of coal out of a mine.
But I will say, there are emissions if we have a bunch of horses. What is the emission from horses?
Does he
Methane.
care to explain?
Methane,
Natural waste.
a very bad gas for the atmosphere. Just like how we have a ton of cows that could produce methane. If we had a bunch of horses, we'd have the same problem.
That's right. A few more points on oil. We've obviously all heard about it. We know gasoline comes from it. We know a lot of different products are made from it. But the price of oil is set by global supply and demand. There's a couple of different organizations that come into play when you talk about the price of oil because they tend to control the supply of it. Right? A country can determine how much oil it wants to export or sell to the global market And there are some organizations of countries that have kind of come together, banded together to work in common interest with one another. The issue that we see come from that, or one of the downsides of oil, is that depending on the price of oil, it can have a serious effect on the global economy, as well as politics. And I would venture to say that the politics tend to come first because of the organizations and the countries that supply the most oil to the globe. I think you saw some of that in your lecture and in the notes about how much oil is coming from which countries. But it can have a major effect on the global economy. For instance, OPEC, or the Organization of Oil Producing Countries, that tends to control the supply of oil and the price from the Middle East, which accounts for over 50% of the world's oil supply. They can really make life difficult, or domestic oil very expensive, by either producing more or less. Typically, if they produce less, the price of oil will go up. Still follows the rules of supply and demand, right? I think one of the other interesting questions I saw in the assignments were that some may have struggled with was, if the United States, is one of the largest oil producing countries in the world, why does it still import oil?
Because we use more than we make still.
That's right. If you consume more than you produce, you are in a deficit.
Bad situation.
Well, it means you've got to make up for it somewhere, right? If you're
Especially
using
whenever
more
you're
than
the
you
top
produce.
oil producing country.
We use
Well,
lots.
we're not the top. We're one of. I think we may be number 3, but
I'm
and
Canadian.
that's in volumes per day. How much?
I'm
Yeah.
Louisiana and Texan.
How much oil do you think Canada produces? A significant amount of oil per day, but they tend to use most of it.
Um,
Can you go back to the last slide real quick? I just want to say
I
something.
think the reason we use so much oil is because we're using oil to make all those Fords and Chevys, and then we're driving all those Fords and Chevys because they all run on gasoline and diesel.
Yes, we know that transportation is a major use of oil and its derivatives.
All right, so my chemistry brain wants to ask, who can tell me at what point oil becomes a vapor according to this chart?
Water, I mean, wait, I know that
25
olive oil-
degrees Celsius.
No, I know that olive oil boils at 680 degrees Fahrenheit.
Okay, it's at the very bottom.
350
350.
degrees Celsius.
Okay, awesome. And then it's this long chain hydrocarbon. And as it starts to kind of come back to a liquid, right? The vapor comes up and it's going to condense into a liquid. The long chains, like oils, will settle first down the first pipe. And then at the very top, would that be a long chain or would that be a short chain hydrocarbon?
Medium chain.
Very top.
Oh.
Oh, well, yeah, you're right. A medium chain, because that's petroleum gas. It actually goes farther up. 'Cause you'll have
Well,
methane up there.
they're using petroleum gas to catch all the anes, right?
That's right. Yeah. So if you notice when they distill, I just thought it was very interesting how the temperature changes and how it catches all the different hydrocarbon chains at different levels. That's all.
Cool, right? I'm going to call somebody out because I thought this was interesting as we talk about cars. Sahana and Ava, do you remember, the look of terror on her face. Do you remember what gasoline is made of? They talked about it in one of the videos.
It's on the gas pump.
I really want to say gas.
I really want to say it. I really want to say it, but the
Hold on.
question
There is different
Say
numbers.
again.
I don't know.
No, come on. Can I say it?
Octane and
Come on. Heptane.
heptane. That's right. Two.
Right.
Those are
that's
just
cool.
two chemical things. Oh, good try. That was an extremely difficult question. Don't get upset if you didn't know the answer. That's extremely
My dad's
detailed
car.
information, right?
My dad's car could not.
When you go to the gas pump next time, have your mom show you the octane levels.
87, 89, and 90.
Yeah, which octane level do you want to pick?
And those
91.
the levels of octane are engineered into the fuel for different reasons. A more recent common, but very common additive to see now is ethanol in fuel, which also burns in a car engine, but replaces some of the gasoline. So it makes it a little bit cheaper. I'll leave it at that. All right. So how do we find and produce oil? Like we said, you guys okay over there? All right, all
Never
good.
know.
Finding and producing oil. We talked about how the plankton and stuff get buried, and over tens of millions of years under pressure and temperature, it gets cooked down into oil, and it lives in the pores of sedimentary rocks. You can see in kind of the oil well structure map here how we use drilling and different rigs to access these reservoirs, these underground reservoirs that have the oil, gas, and different fluids trapped in them. So we've got to tap into those. We have to get access to them, and then we have to extract the oil. In a lot of cases, the oil will flow naturally because the pressure inside that reservoir will be high enough to drive the oil out to surface. And we basically catch it at surface. Offshore, it's a little more sensitive, right? If you look at the rig structure and some of the pictures on the right, it shows you the different types of drilling and production rigs we use to access and produce the oil. Offshore, you now have the complication of how do you get the oil back on shore, right? Because that's where the refinery is. So once you get the oil out of the ground, you drilled, you produce it to surface, you capture it, you got to send it to the refinery so it can be turned into the different products we talked about or used to make electricity or what have you. This is extremely prevalent today. It's still the way we do it today, right? And it hasn't changed in a very long time. We've just built bigger facilities. We've built deeper facilities because we know that the oil, new sources, new reservoirs, tend to be farther and farther away. Right, the easy to find stuff they say has already been found. We just have to get better at what we do and create new engineered solutions to access new reservoirs.
Question.
Yes.
How do the oil wells in the ocean float?
How do they float?
Yes, they look heavy.
They're extremely heavy. Or can be. It's Bernoulli's principle. If you displace more water than you weigh, you float. So they basically build these platforms. I've worked on several. They build these platforms like cans, essentially hollow cylinders in some cases, that are then tied to the ocean floor with large chains or tubulars, and that's called a moored platform. Moored just means it's tied to the bottom of the ocean, but the platform itself is floating, and they can pump water into the space to give it a little bit less buoyancy, or they can pump water out of it to raise it up a little bit. But through that hollow cylinder, the wells are connected directly to the ocean floor. So this facility just kind of floats over the top of them and is held in place by mooring chains or mooring lines. It's a highly engineered product, I promise you. And they're incredible to see in person because they can be extremely large. Does anybody remember what the deepest oil platform in the world is? Or the
It
deepest
was
water?
the super deep hole. It
It's
was
like
like
8,000 feet.
48,000 feet deep.
Not the hole, the platform.
Oh,
It's
yeah. I don't
Tito
remember
or
that.
something.
Perdido, that's right. Perdido is Spanish for lost, as it turns out. Like, I have no idea where I am. That's right. It's in 2.4 kilometers of water. That's over 8,000 feet of water.
That's what I said.
Did you know that here in Canada, one of your platforms that isn't floating, the Hibernia platform, is the heaviest platform in the world? Pretty cool.
Wow.
Pretty cool. All right. A little bit more on oil. Here we go.
So with the platform on the other slide, was that a jack-up platform in the other picture?
Mm,
The jack-up rig?
this jack-up rig here? Or are you
Yeah, and
talking about the one
the
in the-
picture below it, is that a jack-up rig?
Our videos.
That's the Hibernia platform.
That's
That's a gravity-based structure that is basically set on the ocean floor via this concrete base with 4 hollow concrete legs.
that made us
That the-
disappear.
Platform is actually set on top of. So that one is actually sitting on the ocean floor. It's only in about what was it, 80 meters of water, or 100 and 200 and something feet of water, I think. And then sticking out above that are these hollow columns of cement that the rest of the structure was built on top of. So that one's actually not floating. It's actually sitting on the ocean floor, kind of like this platform rig you see in the top right corner.
Okay.
It's
so
like that,
like that.
except all that structure is concrete below it.
All right.
Which is also pretty cool because to install it, they actually floated out there, including the concrete. The concrete base, I believe, was built in Norway and sailed across the ocean over here, and then they sank it to set it on the seafloor.
How do they sink it without making like kind of like fall over?
They pump water into it in a very controlled way.
Ah.
That's right. It only floats because it doesn't have water in it. But once you put water in it, it loses buoyancy and it starts to sink. Right. So we talked a little bit about how you have to manage getting the oil from its source, right? The reservoirs underground, the different rigs we use to extract it, and then how to get it to the plant to turn it into whatever it's going to be, energy or products that you buy. That could be done in a number of ways, either by rail car or underground buried pipelines. Sometimes they're elevated pipelines. Barges, super tankers that send millions of barrels of oil around the globe to different markets so they can sell it and trade it, or trucks that go down the highway. Yes, sir. You have your hand up.
How do you farm a crude tank?
Well, it's only called a farm because there's a lot of them all together, kind of like a garden would be.
More like a
You don't
garden.
actually grow and harvest the tanks.
Let's see. That makes sense.
It's a storage facility, right? It's so when you have a lot of crude, let's say one of these large tankers comes in, You have a temporary holding facility of crude oil until the plant is ready to process it, or the refinery is ready to turn it into something else, right? It's like having groceries in your pantry. You're not ready to eat them yet, but you will be. So you just store them there for the time being. I think the lesson did a pretty good job describing where most of the world's oil comes from. I put a map up here from 2019, so it's a little outdated, but the trend has been consistent for a while that the Middle East countries, all banded together, produce over half the world's global oil supply. Russia is a large contributor. The United States, you can see there, and Canada. 4 million barrels of oil a day. That's a lot of oil.
It's a lot of drilling too.
That's right. If you look at the map on the bottom right, I thought this was pretty neat. This is actually a diesel fuel consumption map. So diesel fuel, the liquid fuel you can put into a diesel burning engine, the usage of that, you can look, and it's fairly well tied to where you're getting your oil, except in the United States. We burn mostly gasoline for transportation, especially personal cars in the United States. So even though we're producing a whole bunch of oil, we're using gasoline, but diesel we're sending somewhere else, because Europe, if you see Europe is kind of highlighted in red, they use a ton of diesel fuel for personal transportation. Cars over there have very small, kind of efficient diesel engines in them. So that's why they are using way more than other parts of the world.
Does diesel have a longer carbon chain or a shorter carbon chain than gasoline?
I'm gonna go with shorter.
Why is that?
You think it's a heavier oil or a lighter oil?
Lighter oil than the oil we use with octane and heptane.
Anybody else want to guess?
Heavier.
I'd say 13 to 16 carbon chain versus the octane, the 8 for a.
Is
Right.
both longer and heavier.
Yeah, that's right.
If I flipped, yeah, if I flip back to the distillation column where oil goes in and a bunch of stuff comes out, diesel is farther down on that list than gasoline is.
Yeah.
It's also,
That's
I
the
think,
best. That's the best picture of the cow I've ever seen.
he's happy. He just let out some methane.
Oops.
So natural gas. So we talked about methane earlier. CH4 is the chemical formula for methane, but we commonly call it natural gas. It comes from plants as well, kind of like coal, except that at room temperature, it's a gas. Coal turns into a rock, right? It's a solid. Methane is just a gas. It does get trapped in reservoirs, kind of like oil would be. In fact, it can be found at the top, because it's lighter, of a lot of oil and gas reservoirs, if not in solution with the oil. In solution with the oil in those reservoirs, right? Sibling rivalry. So
You could mute them.
funny. I have. The interesting thing about methane is it could be produced from surfaces, from sources on the surface too. I think the videos talked some about producing methane in landfills, which, if you have methane produced in the absence of oxygen, we get, anybody?
On methane.
Biogas. Decaying plant matter in the absence of oxygen is called biogas. That was the question in the homework that gave a lot of people trouble as well. So it's also very versatile, meaning it can be used for a lot of different things, primarily transportation. You can compress it, kind of like you see in the bottom right-hand corner. You can compress it and put it in a tank on a vehicle, and the vehicle can burn it just like it would gasoline or diesel. Not exactly. You need to make some changes to the engine, but it can burn it as fuel. And these are common. In cities, you'll see buses running on compressed natural gas, right? What would be some of the advantages to using natural gas over gasoline or diesel to run buses on?
It's clean.
What do you
common.
mean by clean?
Well, doesn't.
Remember, clean and dirty are subjective terms that we have to try to quantify, right?
There's less, like, it has less emissions, am I right?
Is that what you were getting at, Em?
Yeah.
Yeah.
What does
Clean.
combustion mean? Just means you're burning
You're
some
you're
sort of
burning
hydrocarbon like
different
methane, right?
combined.
What comes out the other side? Carbon dioxide and
Methane,
water.
water.
That's your clean part, right? Your water vapor.
Right. When we talk about clean versus dirty with fossil fuels, what we're really talking about is their emissions. What do they give off as part of burning them to make energy or make electricity, whatever you use them for? It turns out that natural gas, because it produces mainly carbon dioxide and water, actually has very few emissions. So that makes it cleaner than a lot of other sources of fossil fuels, particularly coal, which we know gives off sulfur compounds, nitrogen compounds, and ash. Literally puts ash into the atmosphere when you burn it, and including oil. So it's a little bit cleaner than either of those two sources to be able to use to make energy.
Okay, I have a question. When Elon Musk launched his rocket, he went from using the long chain kerosene fuel, right, to methane, which is cleaner. Why is that important? He had like, what, 33 rocket engines on there.
Because he's an environmental freak.
So environmental
That's not
maybe, yeah. But what about, why would that be important with all those engines?
Doesn't want to get too hot.
Yeah, because it would burn. It would burn
Yeah,
a
but-
lot.
Would there be residue in all those engines?
Yes.
You have to clean them?
Yeah. Yeah.
No more residue.
Yeah,
No
now
more
you
clean.
don't have all that residue, right? So you want a clean
That's-
burning fuel.
We didn't talk about residue very much as an emission that can come out of burning something, but it is, like Ms. Tara just highlighted, it is one of the things that can come off as a byproduct, right? When you burn something, if it leaves behind a physical residue that you'll then have to go clean up, well, that's not desirable either, because now you have to stop whatever you're doing. Let's say you're making electricity, and in the combustion chamber, you're leaving a bunch of residue. Well, sooner or later, you'll have to stop and clean that out, right? And at that point, you're not making electricity. So that's downtime and works against the affordability or the efficiency of a fuel source. And Miles, you'll have to write a paragraph to me on the definition of an environmental freak in your own words.
It's just somebody that cares too much about emissions and stuff. Like global warming and all that kind of stuff. Yeah.
Write me the paragraph. Describe what caring too much means. All right, so we talked about natural gas being cleaner, and it's actually in some houses, you will burn natural gas at your stove to cook your food, right?
Yeah, I
It's
guess
not on.
so.
Yeah, many people do. It's very common because the stove is tuned to how it burns the natural gas to make sure that whatever it gives off, the emissions, are safe to breathe, meaning there's no carbon monoxide coming off of it that is actually toxic for people to breathe in enough concentrations. It'll make you sick, it'll kill you. So the stove is designed to burn natural gas so cleanly that it doesn't produce enough carbon monoxide to make you sick. Heating furnaces, a lot of those will burn natural gas if they're not electric, right? Two main sources of heating for a home. So again, a lot of benefit, right?
Wasn't Texas like most of our energy came from natural gas,
No,
right?
No.
That was the majority.
no.
Electricity. A lot of electricity
electricity,
comes
yeah.
from natural gas. Like a quarter of the electricity that Texas produces comes from burning natural gas. And we know how that works now, right? You burn the natural gas, you make steam, it powers a turbine, turns a generator, electricity. Right?
Mhm.
Awesome. The rest of the pictures are on the right. We talked about horses and cattle as sources of methane. It's not a joke. There are companies out there today that are working to capture the emissions from cattle, large groups of cattle, to siphon the methane off and then turn it into fuel, right? They're just capturing it, compressing it, and sending it to a plant to be used.
How did they capture cow farts?
That
Not
is an
going-
excellent question.
They
I-
could time
That's
to
what I
watch.
wanna know.
I think that's a good question, but nobody
Not
wants to
going there.
answer it.
Yeah,
Well, none of us know the answer to it.
very, very carefully is all I can
Uh-oh.
imagine.
So you need to be
Um,
careful with cow farts, like they're
you,
delicate.
you need to be careful with a cow.
Yeah.
Cow in general.
And if you're sensitive to smells, yeah, you need to be careful around cow farts too. So it turns out that the most economical sources of natural gas are in these underground reservoirs that we talked about. They tend to be associated with oil reservoirs, but they don't have to be. One of the newest sources of natural gas are in shales. And that's when we start talking about hydraulic fracturing. I don't know if anybody's familiar with the term, but the picture kind of on the right-hand side of the page where you see unconventional and conventional compared, the unconventional picture shows a drilling rig drilling down into the reservoir and then turning to go 90 degrees parallel with the reservoir or the shale that has the gas in it, and then using water injected at high pressure to shatter the rock under the earth. It literally creates a whole bunch of fissures and cracks, fractures in the shale and the rock, which give the gas a place to flow back through and then up to the surface so we can capture it. A very common technique used today. Any questions on natural gas so far?
No.
Nope.
Awesome. I think in general, you guys did really well on all three of the units in the homework based on what I saw. There were a couple of trick questions in there, especially in some of the close notes things where you had to fill in the blank with the words. Sometimes they didn't give you credit if you just got two of them out of order, but I wouldn't let that bother you. What I saw said that you got the concept, and that's what we're after. So if you look at total energy consumption, where do you think, or how much would you estimate of the total energy consumption fossil fuels or hydrocarbons make up based on this chart?
Most of it.
Other renewables.
Look at natural gas, oil, and coal all lumped together. How much, if the top of the curve is 100%, what percentage do you think is from fossil fuels? Those three in particular.
Like 50%, maybe.
Keep going.
70%.
90.
Looks probably like
80.
high 80s to me.
85.
And this chart was built in 2017, but extrapolated out to 2021 a little bit. So there's some error, in everything. But 80% of the total energy the globe needs coming from fossil fuels. Do you think that could open up some issues based on how relied on those fuel sources we are?
Yes, definitely.
What
Yes.
about the emissions that are produced from using them as fuel sources?
Those will definitely increase.
Yeah, I think the answer I was looking for is probably, right? If you are limited to getting your energy from just a few main sources, then it makes those sources very important. There's a lot of things that come with it, but if we now have science to help us understand the impacts in more detail of using those fuel sources in the way we do, then you probably want to understand it pretty well, right? We need to make sure that the sources we're using aren't causing harmful effects outside of them, right? And there's a lot of opinions that say they do. There's some evidence to say that, that data may be a little worse than some people say it is. The effects are less harmful than some people say it is. So there's a lot of energy, for lack of a better word, into studying the effects of where we get our fuel, where we get our energy, and what does the future need to look like. So one, we can continue to grow and evolve as a people, and two, bring other countries into the modern era, right? We already said that over 80% of the global population are not in modernized industrial countries, right? So how do we allow them to develop and provide them the energy they need, give them access to it reliably, affordably, while not causing any harmful effects to the rest of the world?
Give them money.
Give them money.
Hard disagree. Money is not the answer.
What if
That
they're
is
not
my
developed
personal
by,
opinion.
What if, kind of sounds weird, but what if they're not developed by choice? Like, what if like their tradition or religion has them stay in a certain area?
That's a very profound and deep conversation. We talked about political effects around the globe of some countries having more access to fuel sources than others.
U.S. compared to Israel. I don't think Israel has any oil reserves in it. I think it's like the only country in the Middle East that has no oil reserves.
They're working on that. But Emma, I think to your point, there are other factors at play, and there always will be. We are very similar. We're all 99% the same as a human being, but we are individuals in our cultures. Different aspects of that can affect our approaches to different issues, energy being one of them. It's not to say that anyone is correct or incorrect. It's just that we have different approaches, right? No two people will solve the problem the same way. So at some point, as human rights would dictate, you have to make choices. you have to make your own choices, right? And that is for them to make.
What am I gonna do with the Kahoot?
Next, if you don't have any other questions.
I did draw something for my notes during class. If you want to see?
You were doodling during class?
No.
We
Do you all
can't
want me
show
to-
the- Yeah.
Do you want me to pull up the drawings that were submitted in the homework?
Yeah. I pulled some of them. That
I
were
got,
submitted.
again, if it wasn't turned in by,
This morning, I think.
yeah, if you didn't get turned in by this morning, it probably didn't make the slideshow, but let me try to share that screen again.
I tried opening a whiteboard.
I declined it, sir. Trying to share something. All right, anybody want to take ownership of this one?
Yeah. Wait. I need annotation.
Disabled.
That's Caleb and Elijah. Yeah.
Awesome.
I think we turned off.
It's spot on. The illustration was on the benefits versus the cost of coal as a fuel source, including clean coal. So bang on with everything they wrote down, right? He even gave the bad news, or they gave the bad news first, put the cons on the left side and the pros on the right side, right? So, no, I like it. Spot on.
That's really bad. That's all pixelated.
As the resolution.
I'm muted.
Sorry.
The content is spot on, and it's even in table format, right? So chose a modern medium to present on, made a table, pros and cons, labeled it. Fantastic work. And accurate. The data is accurate. Little more creative, little more artistic, still spot on. Non-benefits, smog, acid rain. That's right. Those nitrogen and sulfur compounds that you get from burning coal. Not
That's
great.
mine.
Awesome job.
Oh, that's mine.
Oh yeah,
Benefits and downsides. Again, we get more into the more creative, artistic realm, I think, as we're going along.
I used to
Low
see
cost.
logos.
That's right.
Oh yeah, mine was not any type of diagram. I did not realize. It said you could do a comic, so I did a comic.
Hey, open assignment, right? No, still all good information. Lola wrote a story. I love it.
What is the story about?
Oh, it's coal.
The story of
Got
coal?
coal.
And it has the pros and cons of it in it that are boxed up.
Nice. Way to be creative.
Running cars and refrigerators on the good side, cheaply and simply. Everyone has access to it. But the bad sides are the emissions. Awesome work.
Hey, that's mine.
You
You
made
can
the
all tell.
deadline. Yep.
That's a
Telling the
great
story in
furnace.
pictures, right? Yeah.
Mhm.
I don't know that I say that, but people do still burn coal in fireplaces for warmth, right? And
It's
for
probably
heat.
not very safe.
It is. Well, it's less safe than potentially alternatives, right? Which is how we start to compare and contrast sources versus each other.
Would it be safer than natural gas?
No, right? Because we said that coal will actually produce ash as a byproduct, as well as nitrogen, sulfur compounds, and CO2, where
Oh yes.
natural gas, if burned correctly, will only produce carbon dioxide and water.
That being cold state.
Now you can't breathe carbon dioxide either, at least not that much of it.
Yeah.
But it's better than breathing. Breathing a little carbon dioxide is better than breathing a lot of ash or sulfur compounds.
That was mine.
And quick, simple, to the point. I like it.
Stop. Right.
No, I think you all did really well on the assignments. Honestly, thanks for those who got them turned in and tried.
Is mine here? Did you show all of them?
All of them that were submitted as of this morning, I think.
But I submitted mine yesterday.
I submitted mine a couple days ago.
Let's see.
What's your?
Do you want to show yours?
No, before. What? Sorry?
Do you want to show yours?
Yeah.
Okay.
Mommy? Over down here.
You'd have to get his.
1 second.
Hold on.
Say 1 second.
Peeling down.
Miss Tara, do you have them pulled up or the classroom pulled up?
Yes. I do. What is your username?
Share screen. I think it's like
Yes.
Turkey 2023.
Ah, okay.
Do you see it?
I gotta log into the
Ah.
to the classroom again, but we'll see who can get
It's
there
okay if you
first.
can't find it. It's just
We'll give it a shot. Let's see, that was on coal.
I could have done something wrong.
That's
I don't
why,
know.
because it still has in progress. So if you did your no, I don't.
No, it says it's turned in.
Yeah. I don't have it on mine. Oh, it does say turned in. Yeah. But it doesn't have a picture.
We might have just done something wrong when we tried to submit it. Who knows?
Oh,
Maybe
okay.
we didn't. I don't know. We put the file in there, but maybe we missed something we were supposed to do, and we'll be more careful next time.
Oh,
If you draw it on a
That's
piece of
all
paper
right.
next time, you can just hold it up if you want.
yeah, what did you draw it on?
Oh, there you go. Oh, wait, your background is preventing us from looking at it. There you go.
Yeah, there you go. Nice.
Wow, you drew a lot.
Yeah.
Yep.
Yeah, good work. No, awesome job, everybody. I can really tell you're comprehending what the material is putting across. So, keep up the good work. I think we may try to figure out an incentive for the best grade in the class, in case that motivates you a little bit more to turn in the assignments and do them as best you can. Apply yourselves and all your youthful wisdom and energy.
Do like student of the week.
It'll be, I was thinking something like that, maybe student of the class for the best overall grade, but we'll see.
Am I a student of the class?
There is no one student of the class yet.
What's my
The
grade?
title remains to be claimed, but you're all doing really well.
Oh yeah, Mr. Michael,
Yeah, go ahead.
have you actually like graded our things, or do you just put completed if it's graded?
I'm putting completed for now because this is
Okay.
our first kind of trial and error with this system, and I wanted to see how it was going to work. So I'll ask for feedback as we go. If there's something that you find you like more or less, maybe I can, when I'm building the assignments, focus on doing the things that actually are more valuable than the things that are just like not interesting or less valuable. I'll say I'm not creating the material. I'm selecting from an offering of material and putting that into the assignments for y'all to do. Okay. So if there's any feedback, feel free to pass that along. I did put comments in next to some of the assignments this time. But again, we're just going to make sure we get the most out of it that we can. So
Do you want to see my drawing, or should I
Yeah.
just send it to you?
you better hurry before the Kahoot starts.
Okay, here it is. I made a whole goddess out of the notes I made, and
That's awesome. Is she the goddess of fossil fuels
yeah,
with
her
the
hair is
three-pronged trident?
her hair is CO2 from like all the emissions, and on her dress she has like bottles of methane for some reason.
Awesome. That's what I love the most about this group. Y'all are so creative and imaginative. Don't ever stop doing those, right? Bring them with you in whatever you do. It'll serve you well. All right. Well, y'all enjoy the Kahoot, and I will talk to y'all again next week. The assignment for next week is up. I put it up this morning, and we're going to talk about nuclear and some of the alternative energy sources.
What? 3.
Thank you very much for having the class.
See you
My-
tonight, Dad.
My pleasure. See you later.
Bye.
Bye.
Thank you. Thank you.
Bye.
Miss Tara.
Yeah.
Wait, can you record the Kahoot?
No.
I think it's still recording.
Yes, still recording. Don't stop recording.
It did.
No, it's still recording.
Oh, okay. Yeah.
Never mind.
Oh, bro.
All right, everybody.
I'm not
Got
in.
it.
I'm not in.
Game pin
Chinese,
504 6783.
Yeah, in space.
Hold on, I'm still connecting. I gotta.
Now, I must say, I did not make this Kahoot, so I don't know how difficult Mr. Michael made it.
No. Wait, did Mr. Michael make it then?
Yes, because I was sick the other day, so I didn't make it.
Oh.
So we'll see how difficult this one is.
I'm still connecting.
Leland, who are you this time? The Hoot Pack.
Emma, you might have to change servers, remember?
I did. There we go.
Okay.
I like that name.
Mommy. Yeah, we're just waiting for him. We'll start when.
Okay, I'm in.
All right, let me know. We need more time.
My
We got
sister's not over
10.
here yet.
Okay.
This was not.
Like,
so
how do you
big.
do?
What should my nickname be?
Okay, watch. 4 fingers, sweep up.
All right, we
That
got
shows.
9 players now,
Give it a try.
12 participants.
How many
So,
questions are
well, I'm one of them, so.
You need the other one to actually do it.
Yeah.
Wait, hold on.
Who's Emma?
I am Victorian dog.
All right, we got 1 left. Anybody else? Okay, we shall start.
Yeah, go to the thing.
Wait,
Alright.
there was 11. I'm gonna wait 1 more second. Anybody else? Speak now before we start.
Ready.
Ready? Okay.
Yes, I'm ready.
My genius science homeschool.
Ashwin, how dare you send me an image of a cat right as we're about to start the Kahoot?
My name's the same as Emma's.
I don't know. I'm a little bit trolling here and there.
Your little things that he made. And
It's red. It's red. If you don't pick red,
Why
I
does
don't know.
Ashwin, why does he always say the wrong answer?
I don't know. I love spreading misinformation online, so
You
Wait,
also
you
like
post random
talking until the
information
end of-
online?
until the
Don't
Kahoot.
listen to Levi.
Levi's not here.
Yeah, Levi's not here.
Blue. It's blue. Blue.
It's no, it's definitely yellow.
Yeah, we're on the podium. Yeah. Place on the podium. Yeah. Economic.
asteroid.
It's red.
Yeah, it's red. It's red.
Yeah, it's red.
Yeah, you have to pick red.
It's so red.
Everybody pick red right now.
Yellow.
No, it's not yellow.
Oh,
It's either blue or green. Oh, come on. Who's not on the podium?
I'm in 6th place now. This is what happened last time.
It's
Red.
blue. It's blue.
Red.
It's all an
red.
illusion.
No, it's red.
All an illusion. They're lying to us.
It's red. Blue.
Cole doesn't do anything.
Something different, and I picked blue.
It's red.
Oh,
You can easily breathe in coal.
It's
Easy.
red. It's
Light
so
work.
blue. It's red. No, it's literally red.
Don't say
Yeah.
the answer out
Yeah, it's
loud.
red. It's red. It's red as. Red as your mouth and it's
Peanut
injected.
butter and jelly. Peanut butter and jelly. Yeah. It's peanut butter and jelly, by the way, guys. Peanut butter
It is peanut butter and
It
jelly.
is not red. It is red. It is not red.
Red. Easy. Easy red. Easy.
Peanut butter-
If you
Yeah,
don't
it's
pick
green.
red,
No, it's green. It's green. It's green.
I just
if you don't pick red, you like eating raw chicken.
Imagination.
Imagination.
It's imagination, guys.
It's
not.
so red. You just gotta use your imagination.
No, it's yellow.
No, guys. Yeah, it's
I'm
scrubbing. It's scrubbing.
209 points.
No, seriously, we're pollutants to the bag houses. What? The leftover grocery bags. Yeah.
Leftover grocery bags.
Leftover grocery bags, guys. It's leftover grocery bags.
Bro. Oh my god. How did I get that? How did I get that right?
Oh, wait. Who named yourself a Star Wars character?
Oh, wait, we're not on here. What do pollutants?
Scrubbers.
Scrubbers remove?
What?
It's red. It's red. It's red. Choose red. It's red.
Angry person. It's
metal.
Unless that's
angry
some
people
unless
and
that's
the smell
some
of
kind
old
of
gym socks.
yeah.
The smell of old gym socks. Yeah.
Yay.
Yay, I'm in fifth
I'm
place.
behind the toy dog. Oh,
Well, globally, why do most plants not capture pollution? Because there's
I picked red out of randomness because I think
Oh.
it's
I choose. I chose the wrong answer. Dang it.
Let's go. Straight W.
Oh my
Who actually picked red?
I picked red.
It must have picked red out of random.
A little bit trolling here and there.
All right. The biggest weakness of coal is the future.
Dirty.
dirty.
No,
Oh my
it's
god, I
yellow.
clicked yellow. I'm so goofy. No way, I just picked yellow. How am I still on the podium?
Magic.
How dare you be on the podium?
In my country,
I'm going to say availability.
Cost. I mean environmental impact. Sorry.
yeah.
either availability.
It was-
Wait, how? Wait. I didn't even pick that.
Oh,
Wait,
wait,
how?
nice. Electricity for has the potential to lift many developing countries out of.
A losing streak in fantasy football.
Oh my God, yeah, using the streak in fantasy. War. No, poverty. No, yeah, you're right.
No one can get a losing streak in fantasy
I
football.
chose yellow. Yes.
Arrgh. I'm annoyed that it doesn't tell you the right answer after.
I am
Yeah.
too.
Oh,
I think it was because
Dinosaurs,
multiple
dinosaurs.
answers.
I picked green.
No, it's red. It's red. It's red.
dinosaur. I
It's red. It's red. No, it's yellow. It's yellow, guys. Yellow. Yellow.
Oh, let's go.
Dinosaur.
I picked green. It didn't fake out on me this time.
Oh wait, hey, look, it's plankton.
I'm 900 points behind monkey.
Oh, question. These are quiz questions.
High quality H2O.
Bad attitude. Bad
High quality
attitude. Yeah, a bad attitude. It's a bad attitude. These are quiz
Yeah, it's
questions.
blue. It's blue.
We chose the right one.
Pressure.
It's blue.
No, it's yellow.
Yes.
No.
Hey, I'm in 5th place behind
It's
monkey.
yellow.
I'm in. Yeah, I've passed Victorian Hall.
Victorian dog.
Approximately how long to
A microwave.
a microwave.
Like a day. What kind of car is that?
DeLorean.
It's red. It's red.
Back
It's
to the
red.
Future.
No, it's not. It's yellow.
Victorian dog. Can you get one wrong for me?
It's Yoshi and Peach.
Mixed with soap.
Yeah.
Taught calculus.
No, no, it's
Ready
blue.
to
It's blue.
listen.
It's blue.
It must
Blue.
be taught
Blue.
calculus.
No, it's red. Red. Red E to listen.
I'm
Who's
in 5th
Midnight
place.
Summer? Is that
Oh,
Grace?
it turned out to be yellow.
Midnight Summer's me.
Oh. Oh, can you get one wrong, please?
No.
Me too.
Yeah.
Yeah. Yeah.
That. What? Blue. Queen.
No, it's green.
I think it's green. Oh,
No
man.
way.
Whose name is that? Drilling for oil
Blank,
is
blank, blank.
something, something, and something. Difficult, hazardous, and expensive. Easy, safe, and cheap.
Choose the most specific answer.
Green. It's green. No,
Oh,
it's
it's red. I
yellow.
chose red.
Oh, yeah.
Wait. I don't know if it's red or not.
It's
It's not red. I'm gonna scream
yellow.
it up.
It's
Oh,
it's
come
yellow.
on. Guys, it's
Let's
yellow.
No
straight W's in
way.
the chat. Straight
It's
W's in the chat.
yellow.
Yeah, there's no chat in this meeting.
Yeah, I don't
It
know who to
was
say what.
yellow. It was yellow. Yeah. Methane and natural gases, greenhouse gases. Okay. It's more available.
Yeah, it's more available. Everybody too is more available.
It does not contribute to global warming.
No, it's it's red. Yeah.
I chose yellow.
Red. Available.
Yeah.
Wow.
Yeah.
1,000 points behind Lola.
I told you it was red. Because it sounds scary. It sounds
It's just scary.
It sounds very
Yeah.
scary.
It's
That's
yellow.
yeah.
Yellow.
Yellow. Yes, yeah.
Fracking thing.
It sounds scary, guys. Yellow.
No, it's red. It's red. It's red.
Yellow.
Red is very red. Choose red.
Yellow. That's what I'm saying. Yeah, I know. Oh, yes, I took. Yes, it was.
Wait. How is monkey so much better than me?
Current choices based on
Hamsters and wheels.
Cow.
It's
Smiley.
no, it's green.
Yeah. Okay,
No,
sure.
it's yellow. It's yellow.
No, it's yellow. Yeah.
Yellow.
It's yellow.
Oh my god, bro. Are you serious right now, bro? You serious right now?
What is the price of natural gas predicted to remain low? Because less people are using it. Oh, come on. I
It shows
clicked the
yellow.
wrong
I don't even care.
This is the one that I got
It
wrong.
It shows yellow
It's
too. It is not yellow, so you know. It's not yellow.
Yeah, I know. I'm 2,000 points behind Lola. I don't even care anymore.
I'm
Yay. I'm getting closer to monkey.
Common uses for natural gas.
Pokemon Go.
It's red. It's red. It's not really used for
It's red.
anything.
It's red. It's red. And Ferrari wheels.
Pokemon and Ferris wheels.
Oh,
yeah.
Ferris wheels. I read that one.
Red.
I'm edging closer to monkey.
Oh, who's that?
I'm just edging closer.
I bet that's the. How's methane generated? Oh, that's easy. Inject hopes and dreams. Hopes and dreams. No,
Hopes and dreams.
no,
Do,
injecting
do,
water
do,
in tail.
do,
Oh, I actually.
do.
No, it's yellow. It's yellow. Yellow.
It's hopes and dreams. How do we have 11,000?
Bro,
We do. Wait, what the?
Dang it.
Yeah, 11,984 points. How many points do people have? No, what natural gas commercial quantities? Costco. Costco. Yeah,
Costco.
guys. Costco.
Costco wrong.
Costco.
Oh, my
Costco.
dad goes to Costco a lot.
Yeah, I'm fifth again. 900.
Who chose landfills?
What is the source of huge commercial natural gas resources? I don't know what that is. Swamp gas, guys. Swamp. Oh yeah.
It's green.
Yes, we got it right. It was swamp gas. Yes, it was swamp gas. Woohoo! Where are three? Oh my goodness. What is the chemical formula for gas methane? Oh yeah, it's red. It's red.
it's red. It's red.
It's red.
No, it's R2D2. Choose R2D2.
It's red.
It's R2D2. No, we know it's not.
Yes.
It's BB.
I am
No, it's red.
1,000 points behind Victorian Dog.
True or false? The proportion of natural gas. Oh no.
Decreased since 2011. False. It's stayed the same, I think, or like increased.
It would increase due to
Blue.
population.
Blue. Wait, no. It's red. It's red. It's red. It's red.
Yeah.
It's red.
Yeah,
It's
boy.
Great W in the chat.
It's red. It's red.
It's a little
It's red. It's red. It's red. Okay. Red. It's red. What is the produce? Rainbow Skittles. That's Rainbow Skittles. Yeah, it's Rainbow Skittles. That's it's Rainbow Skittles.
Be rainbow
It's
Skittles.
Red.
Taste the rainbow, smell
Yeah,
the
that's
rainbow.
what I said, Rainbow Skittles.
Yeah.
Yes, it is Rainbow Skittles. Ooh, yeah, it's Rainbow Skittles. Our streak is 5. Oh my! Compound is primarily ingredients in plastics.
It's water. It's water. It's water.
Water, guys.
No, I clicked the wrong one. I meant to click yellow.
WWW.
No way!
Let's go. Got it right. How did most people get it wrong?
I meant to click yellow, but I
yellow.
clicked red because of my finger.
Ammonia is what I said last time, and that's what they told me it was made out of plastic. So I think they're like
All of these. Yeah. No, it's
Oh my god. Why didn't I not click all of these? So
Yeah,
weird.
Usually, whenever there
right.
is an option for all of the
Our
above,
ancestor
it's usually
streak is
correct.
1.
it's your top
Oh.
5 in the
Aim
making.
for the
All right, here's
podium.
Yoshi Peach.
As if we're not aiming for it this time.
Bro, it literally says aim for the top next time.
So annoying.
No,
Bro,
it's
what
Who
was
is
I doing?
that?
What was I trying to do?
Who's Luminara?
We got runners up.
Monkey.
That's a Jedi.
All right, who got on the podium? Who's first
Not
place?
me, as usual.
All right.
I did at one point, but I didn't
Hannah and
get the
Ava, were you guys first place? Who was first place?
That's a very good question.
Grace is
wouldn't-
first place.
I got 208.
Who wouldn't get an answer
Grace,
wrong?
that was you?
Grace said she was first place. Yeah.
Good job, guys.
17,000. We were third place.
I got one answer
Who
wrong
is
by
Yoshi
accident,
Peach?
sent me all the way
I'm
down
so
to
bad
sixth
at
place.
this.
We were.
I
Yes.
don't know. I don't
This
know
is
who's
like one
doing
of my
that.
favorite parts of this thing. Why?
It's Miles.
Miles, can you stop?
Yeah.
Thank you. Good job, guys. All right, that is class today. Anybody else want to say anything about our energy?
Sorry for opening the whiteboard.
Arg, not that.
Thank you.
Thank you. Yeah,
All right, guys, have fun. You guys did great.
We got 17,284 points.
I don't know how
Wow.
many points
I know,
got.
somebody
think
had
I got like
20,000 on there.
18,000. Like 18,000 something, but Victorian dog just wouldn't give up his position.
Weren't you Victoria?
Who is Victorian
Yeah, I was.
dog?
Victorian dog.
I was Victorian dog.
Victorian dog.
I was Victorian dog. We were both Victorian dog. There were 2 Victorian dogs. I was one of them.
2 of us.
Good job. You guys would have done better than I would have.
Yeah, I'm gonna disappear too. See? I'm done.
At least get up here.
Woo! Please.
All right, I'm gonna stop.
my
our- Let's see.
Stab my teeth.
Hey, can I be